Welcome, everyone. Today we're tackling one of the most common points of confusion in REST API design: the difference between put and patch. Many developers use these interchangeably, but they behave very differently, and mixing them up can cause real bugs in production. By the end of this presentation, you'll know exactly which method to reach for, and why. Both are HTTP methods for updating resources, but the key distinction is how they update. Put replaces the entire resource, and patch updates only specific fields. Let's compare these two methods side by side. Put is a full replacement. You send the complete resource, and it overwrites everything stored on the server. It is idempotent, meaning calling it 10 times produces the same result as calling it once. Patch is a partial update. You only send the fields you want to change, and untouched fields stay exactly as they are. However, idempotency is not guaranteed with patch. It depends on how the server implements it. Neither method is safe in the HTTP sense, both modify server state. The critical difference is scope. Put is a sledgehammer. Patch is a scalpel. Here's where put trips up developers most often. Silent data loss. In this example, we have a user resource with 5 fields: ID, name, email, role, and phone. If we send a put request with only ID, name, and email, perhaps because our form only showed those 3 fields, the server replaces the entire record. Role and phone are now null. This is by design. Put means, replace this resource with exactly what I'm sending. The server isn't merging, it's overwriting. The golden rule for put: always fetch the full resource first. Modify what you need, then put the entire object back. Never put a partial payload. Patch is the surgical option. Instead of replacing the whole resource, you describe only what changed. In this example, we want to update a user's phone number. With patch, our entire request body is just one field, phone. The server receives it, finds the user, and updates only that field. Name, email, role. Completely untouched. This makes patch perfect for things like toggling a Boolean flag, updating a timestamp, changing a single setting, or handling a user editing one field in a form. One nuance worth knowing: the HTTP spec says patch is not necessarily idempotent. A patch that says increment counter by 1 would give a different result every time. Design your patch endpoints carefully. Let's look at the 3 properties that matter most when choosing between put and patch. First, idempotency. Put is always idempotent. If a request fails or times out, you can safely retry it and get the same result. This makes it very friendly for retry logic and distributed systems. Patch is not guaranteed to be idempotent, so always check your API documentation. Second, data safety. Put can silently destroy data if you send a partial payload. Patch is inherently safer. Unspecified fields are never touched. Third, bandwidth and performance. Put requires sending the full resource every time, potentially kilobytes of data for a one field change. Patch is bandwidth efficient, which matters on mobile networks, high-frequency updates, or large resources. Now let's translate this into practical decision-making. Reach for put. When you're creating a resource at a known URI, for example, to upsert, when you have all field values available, or when you need guaranteed idempotency for retry-safe operations. It's also the right call when syncing complete state from client to server, such as saving a document's full content. Reach for patch when a user edits a single field in a form, you're toggling feature flags, updating a status, or operating on a slow or mobile connection. Most day-to-day update operations in modern APIs are better served by patch. A practical heuristic: if you can answer, "What exactly changed?" use patch. If you're saying, "Here is the complete new state," use put. Let's make this concrete. A user opens their profile settings and updates just their phone number. The wrong approach: using put. Your client would need to first fetch the full user object, update the phone field locally, then put the entire body back. If you skip the fetch step and only send the phone field, you'll wipe out their name, email, and role. This is a real bug that ships to production more often than you'd think. The right approach: using patch. Send only the field that changed. One field in the request body. The server merges it with the existing record. No data loss possible, and much less data over the wire. This is exactly why modern APIs like GitHub, Stripe, and Twilio. Default to patch for update operations. It's safer, clearer in intent, and more efficient. Let's recap. Put is for full replacement. Always idempotent. Requires the complete resource payload. There's a risk of data loss if you're not careful. It is best for upserts and full-state syncs. On the other hand, patch is for surgical updates. It only sends and modifies what changed. There's no risk to untouched fields. Is best for everyday field-level updates. The bottom line. When in doubt, patch is the safer, more expressive choice. Use put deliberately. Only when you truly mean to replace the whole resource. If you want to go deeper, RFC 5, 7, 8, 9 is the official HTTP patch specification. And well worth a read. Thank you for making it this far. Remember, put replaces, and patch modifies. Understanding the difference helps you design cleaner APIs, reduce accidental data loss, and communicate intent more clearly to other developers. If you found this useful, subscribe to Beyond Code with Prime for more practical software engineering lessons, architecture discussions, and real-world development tips. Until then, see you in the next one.